In graph 24.6, we used the matching pennies game to illustrate how we would find a mixed strategy Nash equilibrium. Essentially, we simply drew the best response functions to our opponent's mixed strategy, and then saw where the best response functions overlap to find the mixed strategy Nash equilibrium. The same strategy also allows us to find pure strategy equilibria, because those same best response functions will overlap in pure strategies if there are pure strategy Nash equilibria. We illustrate this here with the coordination game that we introduced earlier in the chapter, the right-left game, where we choose either left or right, and our goal is to match our opponent. This time we'll let lambda be the probability with which you play left, and rho the probability with which I play left. A mixed strategy for you is therefore to choose a lambda between 0 and 1, and the mixed strategy for me is to choose a rho between 0 and 1. If you set lambda below 0.5, then that means you pick left less than half the time. I should therefore pick right, in other words, set my rho equal to 0. If you set lambda equal to half, then that means you say left half the time and right half the time, which means it doesn't really matter what I do in response. I can play left all the time or right all the time or something in between. So any rho from 0 to 1 is a best response to you setting lambda equal to 0.5. And if you set lambda greater than 0.5, it means you'll end up on the left side of the road more than half the time, which means I should definitely choose the left side of the road since I'm trying to match you. Thus my best response to any lambda greater than 0.5 is to set rho, the probability that I end up on the left side of the road, equal to 1.